Let's take a look at this system of three equations, three unknowns, using our Gaussian method to solve it. I will number the equations so that we can use them as references. And the idea is to transform this so that we have this triangular result with the three unknowns in one equation remaining, two equations in another, and finally one equation with one unknown so that we can funnel our way back through to solve this system. So, my goal is to eliminate the first term in the second and the third equation. I'm going to use equation number 1, multiplying it by a -4, and then adding it to the second equation. So every term in number 1 gets multiplied by a -4, which gives us a -4x, -4 times -3y is a positive 12y, -4 times -3z is a positive 12z, and -4 times 8, maintaining equality, gives us a -32. I'm now going to add that to equation number 2, and I'll write that right underneath for our setup for the addition. And the result we will call our new equation number 2. The x's are gone, that was the goal. Adding our y's, adding our z's, and our constant term, we end up with a -27. So, equation number 1 I'm going to leave as is. That's our one equation with the three unknowns. Our new equation number 2 will record here on our way to eliminating the leading or the first term coefficients. Next, I'm going to go back to equation number 1 and multiply it by a -3 so that when added to equation number 3 eliminates that x term. So -3 times equation number 1 will give us a -3x. -3 times -3y is a positive 9y. -3 times -3z is a positive 9z. And -3 times 8 is a -24. I'm adding it to equation number 3, which is 3x plus 5y plus 2z equals 3 from here. The result is canceling out of our x's. 9 and 5 is 14y's, 9 and 2 is 11z's, and -24 plus 3 is a -21. This is our new equation number 3. And we'll report that in our results. We've now have two equations with two unknowns that we can combine to hopefully come down to one equation with one unknown. And if we choose to eliminate one of the y's, we could take equation number 2, times it by a -1, which will give us a -14y, and actually it's going to change every one of those signs when you multiply every term by a negative. We will add it to equation number 3, which is 14y, 11z, and our -21. The y's cancel out, but our z's also cancel out, leaving us with 0 on the left and a 6 on the right. When you have this situation where the variables cancel out, it's telling us that there is no solution. When you get a false statement with no variable, the conclusion is that there is no solution, which means all three planes, and these are the equations of the planes, are parallel, and if they are parallel, it means there would be nothing common to them, or the planes, these equations of the planes, intersect 2 at a time, with no points common to all three planes. That's what's happening, and in terms of the system, when we have no solution, the system is referred to as inconsistent.